All right, I'm going to go through some of these exponents. We had just started practicing exponent rules at school, so this will be a great way for you to review. All right, let's look at this first one. It's a multiplication. The rule for multiplication is that we add these two together. So we end up with x to the 2 plus 4, which is x to the 6th. Okay, so that matches with 11. I'm just going to write 11 over here and cross it out. That way I know I've used that one. And the great thing about these kind of worksheets is they're self-checking. If you get an answer and then that's not one of the options, you know you did it wrong, and that way you can try again on it. Let me skip ahead, see what else we have. How about A down here? Let's look at this one. So this one has both numbers and exponents. So we have many problems of 3 times 2 and also x squared times x. Now 3 times 2 is 6. X squared times x, this has a 1 here, and so again, just like our first problem, we're going to add those up so we get x to the 3rd. So when we take those two back together, we get 6x to the 3rd. You want to think about the individual numbers as their own problem and the exponent part, the x's, as their own problem. And so that matches up with number 20. All right, and then down at the bottom of the page where the numbers are, that's where you will put the letter that you found. And then that should spell something out. The answer to Y is a lame elephant, like adding 19 and 4. All right, let's go to these ones. These ones have a little bit more of a challenge with them because we have multiple variables. So I'm going to do that first one. I see plain numbers, 4 and 3. So 4 and 3 will be their own problem. And then I see ins, so ins will be their own problem. So I've got n to the 3rd times n squared. And I have t's, so t's will be their own problem. Okay, so I solve each of these on their own. So I've got 4 times 3, I get 12. N to the 3rd times n squared, that means that I add them, I get n to the 5th. T squared times t to the 4th, I will get t to the 6th. Okay, so my final answer then is to put all those together. I'm going to have 12 n to the 5th, t to the 6th. And I look over, and that is number 9. All right, and let's move down. I'm going to look at this one here. I don't know why the negatives are like higher up. Usually we write them in the middle, but that's what that means. So we do have a -1 out in front there. That's a -1. We're going to have -1 times 8, which is -8. We then have n squared and no other n's, so that means we just have n squared. They're not combining with anything else. And then we have our t and our t to the 3rd. So we've got t and, sorry, I make my t's weird. Let's not do that. T times t to the 3rd. This is a t to the 1st, so we add those, we get t to the 4th. So we are looking for -8 n squared t to the 4th, and that is number 21. Okay, and in our next section here, pretty much the same. I had not mentioned it before. Let's talk about E here. We have 2v squared plus 7v. V squareds are considered their own thing, and v's are their own thing. So what we really have here is like if we don't use v squared and v, because those look similar, we can say, okay, v squared is a blue circle. So if I see any other blue circles, any other v squareds, I can make them blue circles, but I don't. I don't have any other v squareds. Then I have v's, I'm going to call those red squares. Any other v's? Red squares. So I'm really just combining like terms here. Well, I have 2 blue circles and 7 red squares. I do not have any like terms. And so really, we end up with that already being simplified. Okay, we cannot combine the v squareds and the v's. Now, if I had had 3v squared plus 2v squared, then I can say, okay, well, I had 3 of my, get my color here, 3 blue circles and 2 blue circles. Those are both blue circles. So how many blue circles did I end up with? 5 of them. So 5v squared. But they do have to be the same.